So my PhD project is focusing on understanding how when individuals complete exercises, how that generates mechanical forces on their skeleton, and how we can relate those external forces to the internal stresses and strains in their bone, and ultimately how that triggers an adaptive response. And ultimately, we would like to know how exercises can be designed or optimized in order to provide increased bone strength in women in a way that could offset osteoporotic bone loss and prevent fractures later in life. So it's really about empowering young women to make decisions about what they're doing now in terms of physical activity to best set themselves up for after they go through menopause. A large gap that we're trying to address with this project is the ability to estimate bone mechanics, and to do that we need to simulate how external forces cause small deformation in bone tissue, and we can't measure this directly, so we use Abaqus, which is a finite element software which allows us to simulate mechanical loading to estimate strain in order to relate that to bone adaptation. I've been able to work with some of the high-performance computing faculty on campus to enable us to build more advanced models in Abaqus and using high-performance computing to solve those models. The Abaqus software is kind of the key link that lets us go from those externally measured forces to strain, which is what we're really interested in studying and what we think is the important variable for answering some of these scientific questions. So we're given the power to make a lot of different modeling choices. There are also many different parameters involved in biological systems, so trying to figure out what are the most important variables without getting too bogged down in the details. So that's something that we're constantly thinking about.